Hello, exceptional students of Mrs. Whitney's. Welcome to Unit 5, which is all about ratios and proportions. So this is section 5.1, and we're going to talk about ratios and ratio tables. And if you remember, I've been talking for a long time about the fact that this, a number over another number, is three things. It is a fraction, it is a division problem, and now it's a ratio. And we're going to talk about this for a little bit. So it's the comparison of two quantities. The value of a ratio is, we say, a to b or a over b, which describes the multiplicative relationship between the quantities in the ratio. So everything that we'll be talking about now is going to be multiplication and division. Every once in a while I might bump into some addition, but I'm going to try to keep that to a minimum. So an example of ratios is 2 snails to 6 fish. So every 2 snails, there's 6 fish. If there was 4 snails, then there would be 12 fish. See how it's a multiple of each other? And 1/2 cup of milk for every 1/2 cup of cream. So if you had 1 cup of milk, you would have twice as much cream as here, so you would have 1/2 cup. So the ratio of A to B can be written as A dot dot B. You can also see it as A to B, and our personal favorite, which is A over B. So a ratio that describes the same relationship are of equivalent ratios. The values of equivalent ratios are, well, they're equivalent. You can find and organize equivalent ratios in ratio tables by adding and subtracting quantities in equivalent ratios and multiplying and dividing each quantity. We're going to multiply and divide. So let's talk about writing and interpreting ratios. So you're making lemonade, and for every cup of water, you're going to need a 1/2 cup of lemon juice. Gosh, I hope there's a lot of sugar in there, but we're not going to talk about that today. So it says to write ratio of water to lemon juice. So we have 1 cup of water for 1/2 cup of lemon juice. And that's kind of the relationship that it has. If we would write it as a ratio, so that's sort of words as a ratio, it would be 1 dot dot 1/2. So now it says to find and interpret the value of the ratio from part A. So we would take this, and so we're looking for the multiplicative relationships. In other words, what can you multiply one by to get to the other? So if we doubled the water, you'd have 2 cups of water and you'd have a cup of lemon juice. So we need to find that number that we would use to multiply one by the other. So we would write it as the ratio, so 1 cup for every 1/2 cup of lemon juice. And we know that 1 divided by 1/2, and since we're dealing with fractions, we can use our old friend, the elementary school division. Otherwise, we think about it like this. But in fractions, it's easier to say, well, that's 1, keep it, change it to multiplication, and then multiply by the inverse. So we have 2 over 1. So this equals 2. So this means the amount of water is 2 times the amount of the lemon juice. So the amount of water is 2 times the lemon juice. So for example, if you had 2 cups of water, we multiplied 1 times 2 to get to the 2 cups. So therefore, you would have to multiply the 1/2 times 2, which would give us 1 cup of lemon juice. If you wanted to double the recipe. Kind of makes sense because multiplying by 2. 2 cups of water. Okay, let's do another example. So now you're going to make flubber using the ingredients below. I didn't choose this one. So we're going to write a ratio of cold water to glue. So cold water is 3/2 cups of water per 2 cups of glue. So per 2 cups of glue. And so the ratio is 3/2 to 2, or 3/2 ... 2. So now we're going to find and interpret the value of the ratio. So we're going to take 3/2 and write it as a fraction over 2. And we know that we can write this using our old elementary school division. So we're going to keep the first number and then multiply by the reciprocal. And that would give us 3/4. So we know that for so the multiplicative relationship is 3/4. So the amount of cold water is 3/4 the amount of glue. Okay, so now let's talk about ratio tables. So here we have a ratio table that says we have 3 cups and 3/4 of a quart. It's, I don't know what it is. It's 3 cups of flour to, I don't know, quarts of water. That would make kind of a nasty pasty stuff, wouldn't it? Maybe it's 3 cups of water. Oh, well, I don't know. Anyway, it's 3 cups of something to 3/4 of something. 3/4 of a quart of something. So we know that going from 3 to 12, and since this is a ratio table, we know that they're all multiples of each other. You know that you had to multiply 3 times 4 to get to 12. Well, if you multiply this by 4 to get to 12, you also have to multiply 3/4 times 4. And that gives us 4 divided by 4 is 1, so that gives us 3. So 12 cups of water and 3 quarts of something or other. So the book actually has you adding, and I'm not a really big fan of ratio tables and adding. So we're going to kind of say, well, since these are all in proportional relationships, we're going to say, how do we get from 3 to 15? Well, for that, I have to multiply by 5. So I'm going to take 3/4 and also multiply it by 5. So 3/4 times 5 gives me 15/4. So this would be 15/4. Now, if I have 15/4 here and 5/4 here, it means I'm getting less. So I had to divide by something. So in order to go from there to there, the 4s are the common denominator. That doesn't change. So I know that this is, I divide this by 3. So this is divisible by 3, which means I have to take the 15 and divide it by 3, and that gives me 5. So that's how you can fill in the missing parts of ratio tables. And you're going to go on to do your notes for future forgetful self. I would show an example of a ratio, or how to manipulate a ratio table, and how to write a ratio and simplify it so that it's the multiplicative. Thanks, dogs. Thanks for watching. Bye.